Here's a loop that a young Mr. Lubbs is going to attempt to run. Now, here's the idea. This is a loop. This is going to go in a circle, but the circle is straight up and down. It's actually a circle with radius r. So now, here we go. As I'm moving along, as I enter the ramp, we're going to call this point A. As we move up here, I'm at point B. As the crowd is getting excited and I'm moving my way around the loop, here's point C. And now, oh no, what if it breaks right there? And then we keep moving and we're coming down. Hopefully things are going well. Point D. And then we make the loop and we come down and we go out to over here. Yay! Alright, let's take a look at the free body diagram at each point. So now, when we here at part A, I'm beginning to go into the circle. The free body diagram at point A, I have gravity pulling down on me. Gravity's always pulling down on me. Let's take a look at that again. Gravity's pulling down on me. So gravity's pulling down. The normal force from the track is pushing me up. I'm going in a circle. So remember, in each one of these, sum of the forces have to equal ma. So now, towards the center is positive. Towards center is positive. I'm going towards the center. That's positive n minus the force of gravity. That's going to equal my centripetal force. Let's take a look at part B. As I'm over here at part B, gravity is pulling me down. Force of gravity. However, the normal force is pushing me towards the middle of the track. So the normal force is pushing this way. Push in opposite directions. The normal force. So what about there? There, the normal force is my only centripetal force. Force of gravity is in a different direction. Let's take a look at part C. Here at part C, well, gravity is pulling me down, and the track is pushing me down. So over here I have the normal force, and I have the force of gravity. And remember, towards the center is positive. Ooh, that didn't show up. Towards center, that's positive. It's in the positive direction. So the sum of my forces here, that's in the positive direction, and now the force of gravity is in a positive direction. That's got to equal my centripetal force. And finally, back over here at part D. Nope. Part D, where I'm coming back down, and everybody's getting excited. Gravity is pulling me down, and the normal force of the track is pushing me towards the middle. So it's going towards the middle. And again, the force of gravity. But towards the center is my positive. This is towards the center, so the sum of my forces in the centripetal direction are just n, and that's just my centripetal force. That normal force is the track. That's how hard the track is pushing on me. Where does the track push the hardest? The hardest? Well, it's got to be where this n is the largest. Where is n the largest? Well, we see at part B and part D, the normal force is simply the centripetal force. So those two are the same. So it's either at A or at C. One of those is going to give me the largest normal force. So let's take a look at it real quick. Here, the normal force equals the centripetal force, the force that's turning me, plus the force of gravity. over here on part C, the normal force is the centripetal force minus the force of gravity. Here is where the track pushes the hardest. That's where I need to make sure I have extra braces down here. And actually, if I wanted to, if I had the seam right, I could actually put a gap there. Why? Because if this normal force goes to 0 here at C, if the normal force goes to 0, I have no track there, gravity can be my centripetal force. That's why when you see it, if they do it just right, they can put a gap there, and when Mr. Lubbs comes through and he reaches this point, if there's no normal force, if I'm going the right speed, gravity will be my centripetal force, and hopefully I'll get all the cheers and make a little money on the side.